To solve a nonlinear system of equations by substitution. This is a nonlinear system of equations, as evidenced by the square in the first equation. That makes it nonlinear. The bottom is linear, but together we can solve this system by using those two equations together. Your first step is to figure out which equation contains a variable that can easily be isolated by itself on one side. Well, if you look in your first equation, you already have y by itself, and it's equal to a negative x squared plus 1. So that step is done for you. You're going to use this negative x squared plus 1 and put it in the other equation where you see a y. So it's going to be 2x plus, and instead of y, we're going to put negative x squared plus 1 in parentheses, and then equals 1 that goes along with it. Since this was already set equal to y, we're using the expression it's equal to plug it in for y in the other equation. And here it is. Instead of y, we wrote parentheses in that expression. Next up, you have to simplify. So 2x minus x squared plus 1 equals 1. We just removed the parentheses. Plus a negative x squared is the same as minus x squared. So now you're in a position where you have 2x minus x squared plus 1 equals 1. You need to try to make a quadratic equation out of this so that it can be solved. We have a minus x squared already on the left-hand side of the equal sign. So we'll put that first. And then we have a plus 2x. But now we have a plus 1 that's on the left, and this 1 comes over with it and becomes minus 1, so that we have nothing but 0 on the right. You've almost put this into a quadratic formula or quadratic equation form. You have just one more thing to do. You can simplify the back end here, and 1 minus 1 is 0. So there's a quadratic equation. It's a negative x squared plus 2x plus 0. We need to solve for x. You can solve for x by completing the square, factoring, or using the quadratic formula. The choice is yours. In this example, I'm going to use the quadratic formula to get a negative 2 plus or minus the square root of 2 squared minus 4 times negative 1 times 0 over 2 times negative 1. And simplify that the best I can to get negative 2 plus or minus the square root of, and this will be a plus sign in here, but you'll end up canceling out that side because it's going to be 0. So you're left with 4. 2 squared is 4. And then a negative 2 on the bottom. So continuing on with that, you have two problems to do. Negative 2 plus 2 over negative 2, and negative 2 minus 2 over negative 2. So in the first one, here, you have 0 over negative 2, so the answer is 0. And then on this one, you'll have a negative 4 over negative 2, which would be a positive 2. So you now have two solutions for x. But we have yet to solve for y. And you're going to solve for y by using both of your x values once each time and plugging them back into one of those two equations to see how they come out. I always choose the one that looks the easiest, so I'm going to use this one. 2x plus y equals 1. 2x plus y equals 1, and we'll put that right here. Remember, we came out with 2 and 0 for our solutions for x, and those are the ones that we have to choose for this. So we'll have 2 and 0 that we have to plug both of those in for x, but you can only do one at a time. So 2 times 2 plus y equals 1. So we come up with 4 plus y equals 1. So y equals 1 minus 4, and you'll have a negative 3 in this case. But now we have to do it again, and this time 2x plus y equals 1, we're going to insert the 0 that we also found for x. So 2 times 0 plus y equals 1 means that we have 0 plus y equals 1, and y would equal 1 in that case. You'll express your answers like this. In this case, we put in a 2 and came back with a negative 3. So 2, negative 3 is a possible solution. And then down here we plugged in a 0 and came back with a 1. So you would also have 0, 1. If you can make it to this point, then you're doing well. We'll continue on further at another time where we go back and check those in the other equation to make sure that they come out right. But this is a lot to do to start with, so we're going to leave it here and then continue on from there tomorrow. This system of nonlinear equations can be solved by first finding a variable that is equal to something, in which the variable is by itself, isolated to start with. And you'll notice that we have y on the left-hand side in the bottom equation. It is equal to this. So we should be able to use that x squared minus 1 and plug it in here. So when we do that, we have x plus the quantity of x squared minus 1. And then set that equal to 11. Now plus a quantity doesn't change the signs, so we can just rewrite it dropping the parentheses. Now you have an x squared, an x, and some constants. That means you can make a quadratic equation out of this. So just shuffle the x squared over a little bit. It still stays on the same side, and then trade places with that x. But you have a minus 11 that's going to come over from the right side and join that minus 1. X squared plus x minus 12 equals 0. And that is the quadratic equation that you're going to have to solve to get the values for x. Now you can factor, use the quadratic formula, or completing the square. In this case, this one is easy to factor because it breaks up as x plus 4 and x minus 3. Which means you will have x plus 4 equals 0 and x minus 3 equals 0. That leaves me with a negative 4 or a 3 for x. But we have not found y yet. And up at the top, x plus y equals 11 is going to be an easy equation to use. So we will go up there and use that with the negative 4 and the 3. So x plus y equals 11. We have a negative 4 and a 3 that we can plug in. If we put a negative 4 in for x, we're going to come back with 11 plus 4. And that would give us a 15. Just as a reminder, we had a negative 4 for x down here, and we just plugged it into this equation to find the value of y. And it comes back to be 15. Now the other number is 3. So x plus y equals 11. And if I put that 3 in for x here, I get 3 plus y equals 11. 11 minus 3 would give me an 8. So we end up with, at the top here, we plugged in a negative 4 and came back with a 15. And below that, we plugged in a 3 and came back with an 8.